Welcome to this tutorial. Today we'll continue our series in modeling with Uppaal. So today we'll go for more details on how to model using Uppaal. So we will know the different types of locations and how to write the invariants in the locations, also the edge and the selection of the edge variables and how to declare the variables in Uppaal. And we end with some examples. As we learned previously, modeling in Uppaal can be seen as three parts. The first part is modeling language. Second, it's simulator and model shaper. In modeling language, actually, we develop the model. So in model language, we develop the timed automata. Since the modeling using Uppaal, it's based on timed automata, and the model is a collection of timed automata. So we should learn everything related to timed automata. Here we should learn the location and different location and the variables, the clocks, the type of channels. So everything is related to developing the model consider under the modeling language. So in modeling language, it's focusing on everything is related to developing the model, developing the timed automata. So in this class, we focus on modeling language, which is anything related to modeling or developing the model. So today we will learn what's the location and what the different type of location, what the different type of variables that can be used in Uppaal, and what the clocks and how we can use clocks and what the different type of clocks and how to create the function and procedure, and everything is related to creating and developing the model. So in general, we can say that the model is a collection of location, edge, and nails. So the location is the nodes or the states of the timed automata. The edge is the transition from one edge to another, from one state to another state, from one location to another location, and the nails is just to edit the edge. The location, actually, we have different type of the location, and each location or each node here is considered as a location, and the location you can name it, you can change the types of these locations. We have three types of location, and we will see an example of these three location and what the difference between them. In the location, we can add invariants. So once we add any invariants here, that means this location you cannot. It's so the invariance in the location is actually its conditions that should be satisfied or should be true since you are in these locations. So here is more details about this window, which is the properties of the location. So the name, the invariants, the different type of the location. We have initial location, origin location, and commit locations. In origin location, actually, the time is 0. In the commit location is origin location, but we just small difference that the next transition should be also must be from another from a commit location. So here the different this is the three types of the three types of this location or nodes. So as we say, the first is initial location, the second is origin location, and commit location. So in the initial location is the start point of the timing automata, while the origin location is a location but the time is freezing, so no delay in origin location. The commit location it's exactly is an origin location. That means the time is freezing and the time is zero. But here it's one more thing is that the next step or the next transition should be from commit location. We will see the use of this type of locations. So here, there the example of timed automata with different location. As we see is we will look different since this is the initial location, origin location, and commit location. The invariance, as we see, the invariance is for the location. So the invariance can be is a condition, and this condition can can use the clock or can use normal variables, and should be true. Should be the true, and in this is that's mean it's evaluated as a boolean, so it should be true to stay in this location. Otherwise, we should do the system will leave to the next. So here, as we say, is only the clock integer constants can be used for comparing the comparing or as a part of the of this express condition. Edges. The edge actually is the line between two locations or between two states. So the main use in this in the timed automata is to transit from one location to another location. Another use of the edge is to communicate with another timed automata. So here we should to add a channel in this edge, and they can be used for communicate another location. And then we can use it to set ID for the timed automata. So here we can use it as a selection. And the last use is can be used as guard. So to allow the system to pass to next location or not. So to use it as a guard, we should add a condition, express condition to allow the system to pass to the next location or not. So here this is the edge, the main use as transition between the locations, and also it can be used as a channel to communicate with another timed automata, and the third use as a selection. Also it can be used as the guard. So here this figure is show different use of this uh, of this line, the edge. So here is just different use of the edge as channel, as selection, as guards. So the different use of the edge is shown in this figure. So here is the properties of the edge. Once you double click on the edge, you will get this window, and here you can change the properties of this line or this edge. So here the selection is just defined as a variable integer, for example, from 1 to 0, from 1 to 3. So there is then we'll have a 3 selection for this variable. Guard is a express condition to allow the transition from one location to another location. Sequence is the channel, and then last is the update to assign a value to any variables. So here, as I mentioned, was the selection. The selection is ID and is defined by this way: ID and then semicolon and then the type that we know we want to use it. For example, integer, and then between two brackets we can limit it the identifier. For example, if we identify like this, so we have this n is take the value from 1 to 3. Or if we just write n, so it take the limited of integer variable, so it take the limitation of the integers or the rank of the integer. Here is the selection and how it's used. As I mentioned, for this now one integer is the value is from 0 to 3. So once we go to the simulator, we will find 3 timed automata. That means in each timed automata it's take 1. So the guard on the edge, actually, as we see, is express condition that must be satisfied to allow transition from one state to another state or from one location to another location, and should be true. And here we say that is side effect free. That means we cannot use it for assignment. There is no assignment value there. The value of this guard is boolean, so there is no effect for another. There is no effect on another variables. So the uh, what type of elements that can be used? So we can use the clock, we can use integers, we can use also constants. Synchronization. The synchronization is the channel. So we can define the channel on the edge. So we have also different type of channel. So in case we want to communicate two channels, so the receiver and the sender should take different type of channel. So as a sender, as receiver. The update which is used for assign a value to the variables, clocks or another types. So here it's more details on the edge and what each section is. So the selection, the guard, synchronize the channels, and the assignment with example.